Manipulating zip files with Python. Python's zipfile is a standard library module intended to manipulate zip files. This file format is a widely adopted industry standard when it comes to archiving and compressing digital data. You can use it to package together several related files, and it also allows you to reduce the size of files and save disk space. Most importantly, it facilitates data exchange over computer networks. Knowing how to create, read, write, populate, extract, and list zip files using the zipfile module is a useful skill to have as a Python developer or DevOps engineer. In this course, you'll learn how to read, write, and extract files from zip files, read metadata about the contents of zip files, use zipfile to manipulate member files in existing zip files, and create new zip files to archive and compress files. If you commonly deal with zip files, then this knowledge can help streamline your workflow to process your files confidently. To get the most out of this course, you should know the basics of working with files, using the with statement, handling file system paths with pathlib, and working with classes and object-oriented programming. As ever, Real Python has you covered with this video course on working with files, this one covering the with statement, this one on pathlib, and this one on object-oriented programming. The files and archives that you'll be working with are available in the course materials, so make sure you download them to allow you to get up and running straight away. Any code that you see running in the REPL will be using the bpython interpreter. This is a replacement Python interpreter that offers a number of enhancements, including code highlighting and suggestions, but any code you see running on screen will work in the standard Python REPL, which is typically accessed by typing Python or Python 3 at your terminal or command line prompt. So now you know what's going to be covered, let's get started. Getting started with zip files. Zip files are a well-known and popular tool in today's digital world. These files are widely used for cross-platform data exchange over computer networks, including the internet. You can use zip files for bundling regular files together into a single archive, compressing your data to save some disk space, distributing your digital products, and more. In this course, you'll learn how to manipulate zip files using Python's zipfile module. Because the terminology around zip files can be confusing at times, this course will stick to the following conventions regarding terminology. Zip file, zip archive, or archive will refer to a physical file that uses the zip file format. File refers to a regular computer file, and member file refers to a file which is part of an existing zip file. Having these terms clear in your mind will help you avoid confusion while you follow this course. You've probably already encountered and worked with zip files, and files with the zip file extension are everywhere. Zip files, also known as zip archives, are files that use the zip file format. PKware is the company that created and first implemented the file format. They put together and maintain the current format specification, which is publicly available and allows the creation of products, programs, and processes that read and write files using the zip file format. The zip file format is a cross-platform interoperable file storage and transfer format. It combines lossless data compression, file management, and data encryption. Data compression isn't a requirement for an archive to be considered a zip file, so you can have compressed or uncompressed member files in your zip archives. The zip file format supports several compression algorithms, although deflate is the most common. The format also supports integrity checks with CRC32. Even though there are other similar archiving formats, such as RAR and TAR files, the zip file format has become a common standard for efficient data storage and for data exchange over computer networks. Zip files are present in places where you may not realize. For example, Office suites such as Microsoft Office and LibreOffice rely on the zip file format as their document container file. This means that the docx, xlsx, pptx, odt, ODS, and ODP files are actually zip archives containing several files and folders that make up each document. Other common files that use the zip format include jar, war, and EPUB files. You may be familiar with GitHub, which provides web hosting for software development and version control using Git. GitHub uses zip files to package software projects when you download them to your local computer. For example, you can download the exercise solutions for Python Basics as a zip file. Knowing how to create, read, write, and extract zip files can be a useful skill for developers and professionals who work with computers and digital information. Among other benefits, zip files allow you to reduce the size of files and their storage requirements without losing information, improve transfer speed over the network due to reduced size and single file transfer, pack several related files together into a single archive for efficient management, bundle your code into a single archive for distribution purposes, secure your data by using encryption, which is a common requirement nowadays, and guarantee the integrity of your information to avoid accidental and malicious changes to your data. These features make zip files a useful addition to your Python toolbox if you're looking for a flexible, portable, and reliable way to archive your digital files. Python has several tools that allow you to manipulate zip files. Some of these tools are available in the Python standard library, and these include low-level libraries for compressing and decompressing data using specific compression algorithms, such as zlib, bz2, lzma, and others. Python also provides a high-level module called zipfile specifically designed to create, read, write, extract, and list the contents of zip files. In this course, you'll learn about Python's zipfile and how to use it effectively, starting in the next section by taking a look at manipulating existing zip files. Manipulating existing zip files with Python's zipfile. Python's zipfile provides convenient classes and functions that allow you to create, read, write, extract, and list the contents of your zip files. Here are some additional features that zipfile supports. Zip files greater than 4 GB, data decryption, several compression algorithms such as deflate, bzip2, and lzma, and information integrity checks with crc32. Be aware that zipfile does have some limitations. For example, the current data decryption feature can be fairly slow because it uses pure Python code. The module can't handle the creation of encrypted zip files, and finally, the use of multi-disk zip files isn't supported either. Despite these limitations, zipfile is a great and useful tool, and you'll learn all about its capabilities in this course. In the zipfile module, you'll find the zipfile class. This class works pretty much like Python's built-in open function, allowing you to open zip files using different modes. The read mode, R, is the default. You can also use the write, W, append, A, and exclusive, X modes. You'll learn more about these later on. Zipfile implements the context manager protocol, so you can use the class in a with statement. This feature allows you to quickly open and work with a zip file without worrying about closing the file after you finish your work. Before writing any code, make sure you have a copy of the files and archives that you'll be using by downloading the course materials. You can then unzip them using your operating system's built-in zip handling method, shown here by double-clicking in macOS, whereas right-clicking on the archive and choosing Extract All will work in Windows. Create a new directory called Python zipfile in your home folder. Then move into the directory and copy the unzipped files into it. You should see a listing similar to the one seen on screen. Once you have these files and directories present in your working folder, you're ready to open up a Python interactive session and to start working with zip files. To warm up, you'll start by reading the zip file called sample.zip. To do that, you can use the code seen on screen. The first argument to the initializer of zipfile can be a string representing the path to the zip file that you need to open. This argument can accept file-like and path-like objects too. On screen, you use a string-based path. The second argument to zip file is a single letter string representing the mode that you'll use to open the file. As you saw earlier, zip file can accept 4 possible modes depending on your needs. The mode positional argument defaults to R, so you can omit it if you want to open the archive for reading only. Inside the with statement, you call the printdir method on archive. The archive variable now holds the instance of zip file itself. This method provides a quick way to display the content of the underlying zip file on your screen. Its output has a user-friendly tabular format with 3 informative columns: file name, modified, and size. If you want to make sure that you're targeting a valid zip file before you try to open it, then you can wrap zip file in a try except statement and catch any bad zip file exception, as seen on screen. When this code is run on sample.zip, it executes without raising an exception, as before. However, running the code on bad sample zip leads to an exception as the file is not a valid zip file. To check for a valid zip file, you can also use the is_zipfile function. Here, you use a conditional statement with is_zipfile as a condition. This function takes a file name argument that holds the path to a zip file in your file system. This argument can accept string, file, or path-like objects. The function returns true if file name is a valid zip file. Otherwise, it returns false. Now let's say you want to add hello.txt to a hello.zip archive using zipfile. To do that, you can use the write mode, W. This mode opens a zip file for writing. If the target zip file exists, then the W mode truncates it and writes any new content you pass in. Note that if you're using zipfile with existing files, then you should be careful with the W mode. You can truncate your zip file and lose all the original content. If the target zip file doesn't exist, then zipfile creates it for you when you close the archive. In this example, you call write on the zipfile object. This method allows you to write member files into your zip archives. Note that the argument to write should be an existing file. After running this code, then you'll have a hello.zip file in your working directory. If you list the file content using printdir, then you'll notice that hello.txt will be there. Zipfile is smart enough to create a new archive when you use the class in write mode and the target archive doesn't exist. However, the class doesn't create new directories in the path to the target zip file if those directories don't already exist. This explains why the code seen on screen won't work. Because the missing directory in the path to the target hello.zip file doesn't exist, you get a file not found exception. The append mode, A, allows you to append new member files to an existing zip file. This mode doesn't truncate the archive, so its original content is safe. If the target zip file doesn't exist, then the A mode creates a new one for you and appends any input files that you pass as an argument to write. To try out the A mode, go ahead and add the new hello.txt file to your newly created hello.zip archive. Here, you use the append mode to add new hello.txt to the new hello.zip file. Then you run printdir to confirm the new file is present in the zip file. Zipfile also supports an exclusive mode, X. This mode allows you to exclusively create new zip files and write new member files into them. You'll use the exclusive mode when you want to make a new zip file without overwriting an existing one. If the target file already exists, then you get file exists error. If you create a zip file using the W, A, or X modes and then close the archive without adding any member files, then zipfile creates an empty archive with the appropriate zip format. In the next section of the course, you'll see how to read information and files from zip files. Reading information from zip files. In this section of the course, you'll see a number of methods for reading information from zip files, starting with how to read metadata. You've already put printdir into action. It's a useful method that you can use to list the content of your zip files quickly. Along with printdir, the zipfile class provides several handy methods for extracting metadata from existing zip files. On screen, you can see a summary of these methods. GetInfo returns a zipinfo object, InfoList returns a list of zipinfo objects, and NameList returns a list holding the names of all the member files. With these three tools, you can retrieve a lot of useful information about the content of your zip files. On screen, you can see GetInfo in use. GetInfo takes a member file as an argument and returns a zipinfo object with information about it. Zipinfo objects have several attributes that allow you to retrieve valuable information about the target member file. For example, file size and compress size hold the size in bytes of the original and compressed files respectively. The class also has some other useful attributes, such as file name and date time, which return the file name and last modification date. By default, zipfile doesn't compress the input files to add them to the final archive. That's why the size and the compressed size are the same in the examples seen previously. You'll look at compressing files and directories later on in the course. With InfoList, you can extract information from all the files in a given archive. On screen is an example that uses this method to generate a minimal report with information about all the member files in your sample.zip archive. The for loop iterates over the zipinfo objects from InfoList, retrieving the file name, the last modification date, the normal size, and the compressed size of each member file. In this example, you use datetime to format the date in a human-readable way. If you just need to perform a quick check on a zip file and list the names of its member files, then you can use NameList. Because the file names in this output are valid arguments to GetInfo, you can combine these two methods to retrieve information about selected member files only. Sometimes you have a zip file and need to read the content of a given member file without extracting it. To do that, you can use read. This method takes a member file's name and returns that file's content as bytes. To use read, you need to open the zip file for reading or appending. Note that read returns the content of the target file as a stream of bytes. In this example, you use split to split the stream into lines, using the line feed character \n as a separator. Because split is operating on a byte object, you need to add a leading b to the string used as an argument. Zipfile's read method also accepts a second positional argument called pwd. This argument allows you to provide a password for reading encrypted files. To try this feature, you can rely on the sample pwd zip file that you downloaded with the materials for this course. First, you provide the password secret to read the encrypted file. The pwd argument accepts values of the bytes type. As you can see here, if you use read on an encrypted file without providing the required password, then you get a runtime error. Note that Python zip file supports decryption. However, it doesn't support the creation of encrypted zip files. That's why you'd need to use an external file archiver to encrypt your files. Some popular file archivers include 7-zip and WinRAR for Windows, Arc and GNOME Archive Manager for Linux, and Archiver and Keka for Mac OS. For large encrypted zip files, keep in mind that the decryption operation can be extremely slow because it's implemented in pure Python. In such cases, consider using a specialized program to handle your archives instead of using zipfile. If you regularly work with encrypted files, then you may want to avoid providing the decryption password every time you call read or another method that accepts a pwd argument. If that's the case, you can use zipfile setPassword to set a global password. With setPassword, you just need to provide the password once. Zipfile uses that unique password for decrypting all of the member files. In contrast, if you have zip files with different passwords for individual member files, then you need to provide the specific password for each file using the pwd argument of read. Here, you use secret1 as a password to read hello.txt, and secret2 to read lorem.md. A final detail to consider is that when you use the pwd argument, you're overriding whatever archive-level password you may have set with setPassword. If you call read on a zip file that uses an unsupported compression method, this raises a not implemented error. You'll also get an error if the required compression module isn't available in your Python installation. In the next section of the course, you'll see some other ways of opening and reading the contents of zip files. Other methods of opening and reading member files. If you're looking for a more flexible way to read from member files and create and add new member files to an archive, then zipfile's open method is for you. Like the built-in open function, this method implements the context manager protocol, and therefore it supports the with statement. Here, you open hello.txt for reading. The first argument to open is name, indicating the member file that you want to open. The second argument is the mode, which defaults to R as usual. Zipfile open also accepts a pwd argument for opening encrypted files. This argument works as the equivalent pwd argument does in read. You can also use open with the W mode. This mode allows you to create a new member file, write content to it, and finally append the file to the underlying archive, which you should open in append mode. First, you open sample.zip in append mode. Then you create new hello.txt by calling open with the W mode. This function returns a file-like object that supports write, which allows you to write bytes into this newly created file. Note that you need to supply a non-existing file name to open. If you use a file name that already exists in the underlying archive, then you'll end up with a duplicated file and a user warning exception. Here you write the bytes hello world into new hello.txt. When the execution flow exits the inner with statement, Python writes the input bytes into the member file. When the outer with statement exits, Python writes new hello.txt into the underlying zip file, sample.zip. The second part of the code confirms that new hello.txt is now a member file of sample.zip. A detail to notice in the output of this example is that write sets the modified date of the newly added file to the 1st of January 1980, which is a slightly unusual behavior that you should keep in mind when using this method. As you saw previously, you can use the read and write methods to read from and write to member files without extracting them from the containing zip archive. Both of these methods work exclusively with bytes. However, when you have a zip archive containing text files, you may want to read their content as text instead of bytes. There are at least two ways to do this. You can use bytes decode or IO text IO wrapper. Because zipfile read returns the content of the target member file as bytes, decode can operate on these bytes directly. The decode method decodes a byte object into a string using a given character encoding format. On screen, you'll see how to use decode to read text from the hello.txt file in the sample.zip archive. Here, you read the content of hello.txt as bytes. Then you call decode to decode the bytes into a string using UTF-8 as encoding. To set the encoding argument, you use the UTF-8 string. However, you could use any other valid encoding, such as UTF-16 or CP1252, which can be represented as case-insensitive strings. Note that UTF-8 is the default value of the encoding argument to decode. It's important to keep in mind that you need to know beforehand the character encoding format of any member file that you want to process using decode. If you use the wrong character encoding, then your code will fail to decode the underlying bytes into text, and you can end up instead with indecipherable characters. The second option for reading text out of a member file is to use an IO text IO wrapper object, which provides a buffered text stream. This time you need to use open instead of read. On screen is an example of using IO text IO wrapper to read the content of the hello.txt member file as a stream of text. In the inner with statement, you open the hello.txt member file from the sample.zip archive. You then pass the resulting binary file-like object, hello, as an argument to io.textio wrapper. This creates a buffered text stream by decoding the content of hello using the UTF-8 character encoding format. As a result, you get a stream of text directly from the target member file. Just as with encode, the IO text IO wrapper class takes an encoding argument. You should always specify a value for this argument because the default text encoding depends on the system running the code and may not be the right value for the file that you're trying to decode. In the next section of the course, you'll see how to extract member files from zip archives and how to close zip files after use.